In lesson 4, we're going to move on from our tidy text that we had cleaned up and produced from lesson 3, and we're going to do some very basic analyses. So for example, we are going to learn how to do some basic word counts, and then from those counts, we'll be able to determine the frequencies of those words within a given corpus or body of text. And we're going to be introduced to a new function from our dplyr package. And now if you remember, our dplyr package was from lesson 2, where we learned some of the key functions for manipulating data within that package. In this particular lesson, we're going to focus on a new function called count. And that function basically does exactly what it sounds like it does. It's going to count the number of unique observations within a given variable. So for example, if you remember that Jane Austen book collection that we had gone ahead and converted into a tidy text format, what we did was we took each individual word in this book and we basically created a unique row for each word. And what the count function is going to allow us to do is it's going to allow us to count every instance of a given word in that book. So how many times, for example, does the word family occur? How many times, for example, does the word settled occur? And that's going to give us a very crude indicator of maybe what this book is about, what it talks about. So then after we take a look at word counts in term frequencies, which is basically the number of occurrences of a word in a given book or in a given collection of documents out of the total number of words, we're going to be able to use that count function then to take a little bit more of a sophisticated approach towards identifying keywords or important words. And this is called the term frequency inverse document frequency, which you're going to learn quite a bit more about in your required readings for this lesson. So effectively what we're going to do is we're going to take this TidyBooks data frame that we created, and as you can see when I do some sorting here, you can see that some of these words that occur in this book, let's give an example, sense and sensibility, for example. We can see that the word zealous occurs 2 times. It occurs in Mansfield Park and also persuasion. And effectively what we're going to be doing with this count function here is that we're going to take this TidyBooks data frame and summarize it. So instead of numerous instances of each of these words, effectively what we're going to do is we are going to just have a count for each number of times this word occurs. So let's go ahead and take a look at how we're going to do that. We're going to revisit our book here, Text Mining with Our Book, and it gives an example of how the count function works. So let's go ahead and paste that over. All right, so let's take a look at what it's doing. As you can see, it's using the piping operator. So it's saying with the piping operator from the dplyr lesson 2 that we learned, what it does is we basically specify the data that we want to use up front. So that way, when we use the dplyr functions, we don't have to include the actual data that we're going to be using inside the function. So for example, another way we could have written this is count like here, and then we need to make sure we would include the actual data that we're using up front. So again, we'll use the piping. Both of these are basically the same thing. The advantage of using the piping operator, as we'll see later, is that it allows us to perform multiple functions on the data set without having to retype the data that we're going to be using constantly. So before running this function, let's go ahead and take a look at the arguments in this function. So again, the first argument in most dplyr functions is going to be the data set that you want to use. So in this case, we specified it right there. Up here, we're going to use the piping to say we're going to be using this data set and all these different functions that we want to perform. The second argument in this function is basically saying what column in the data set do we want to do the counting on. So in our case, what we want to do is count the unique number of observations for each individual word. So basically, we want to count the number of times that each of these words occurs in this data set. And then finally, what we've included in here, what's included in the book, is a default argument that's included in the count function. And basically what we're saying is we want to go ahead and sort it ahead of time. So we want to sort it by most frequent words from highest to lowest. So let's go ahead and run this function and see what we get here. And then let's go ahead and take a look at this. There we go. So as you can see, just raw number of word counts across all books. The word miss occurs 1,855 times. And we've gone ahead and sorted it so we can kind of see like the top 10 words in all of these Jane Austen books. And that gives us sort of a sense of like what these books, well, just from some of these terms here, we get a sense of maybe the time period that these books were written. So that's how the count function works. It's pretty basic. We specify a data set, we specify what column we want to go ahead and do the counting from, and then there's additional arguments that we can include within here. But all right, and just to refresh your memory, at this point we've gone ahead and we've told it to count the number of words in our tidybooks data frame there. But we haven't saved it over to a specific object. So if we wanted to save it and then go ahead and use it later, we could go ahead and assign it to something. And I'll just go ahead and assign this to, let's see, I'll just call it word counts for now. And remember our assignment operator, and the lesser used one is the equal sign, but we're going to use the more frequently used operator. So now we can go ahead, assign this counting of these words into its own little data frame here. So let's go ahead and do that. Oh, you can see I made an error here, a typing error. I was trying to figure out what was going on there. So let's go ahead and try that again. Aha, there we go. All right, let's see, there's our word counts. And now we have saved it as a data frame. And as you can see, this is a table data frame. We've got, oh, that's interesting. So within this data frame, across all these books, we have 13,914 unique words. And if you remember when we were sorting it, I noticed some additional cleaning that would need to take place for some of this. We're not going to worry about this, the additional cleaning that would take place at this point though. So at this point we've gone ahead and found the most common words in this book. If we wanted to go ahead and do some visualization of these words, there's an example that's worked in this book. This uses the ggplot graphing package, which we will be using in Unit 2, and we're going to be introducing in Unit 2. But at this point, I don't want you to concern yourselves with this package, just because there's a lot involved here. If you do want to run the code, though, you're welcome to do that. You're going to want to make sure, however, that you have installed the ggplot package, and when we installed the tidyverse package, that went ahead and installed that for us, basically. Just to verify, though, we can scroll down and we can see that ggplot2 is right there. So we can either go ahead and load it from the little package panel over here, or we can just call it up here in our code. So let's go ahead and load that package. Now we see that ggplot is loaded. Again, like all dplyr functions, we can go ahead and specify the data that we want to use first, and then we can perform some functions on this. So we're looking at that tidybooks data set that we created earlier. There it is right there, and we're performing that count function on it again. We're going to remove any words that occur that don't occur more than 600 times. And then you can see we have some additional functions that we're going to learn about in later units. But for the time being, let's go ahead and run this. So as you can see, when we run a plotting function over here and creating charts, we're going to see a new tab that pops up. The tab's always there, but so far through lessons 1 through 4, we've never examined any plots that we've made because we haven't made any plots at this point. But as you can see, we've got the plot right there that was generated, and basically it created just a bar graph of the most frequent words within the Jane Austen books, which is essentially identical to here. So it just took that data that we made and then went ahead and charted it. And some things we can do, you'll see that it's going to adapt itself based on the size of your window here. And we can also export these charts if we wanted to use them later. But like I said, we're not going to concern ourselves too much with the ggplot package and set of functions for Unit 1. We're at this point just focused on the basics, like just getting our data organized and tidied up and tokenized and removing our stop words, and then doing some basic word counts. So at this point we've got a little bit of insight into our text based on counts of words within our corpus of documents, in this case our Jane Austen books. What we're going to look at next is something called term frequencies. And to figure out the term frequency or the word frequencies that occur within these books, what we're going to need to do is effectively find out how many total words are within this corpus of books. And we're going to work through an example from the Text Mining with R book in Chapter 3. Now when we get to the tf-idf function, this is basically going to do this for us, and the only thing we're going to need to include in it or to produce for it is just the word counts, which we've just learned how to do. But let's go ahead and work through this example. So this uses the dplyr package. I already have that loaded, have the Jane Austen package loaded. We've got our tidy text package loaded. So let's go ahead and copy this over just to our workspace for now. All right, so that's our plotting up there. There we go. All right, so let's take a look at what's going on with this code here. So basically what we're going to be doing is we're going to be creating a new object, and we're going to start fresh by taking all of our Jane Austen books. So this is a data frame here. I think we looked at that in a previous lesson. And what we're going to do is tidy up these Austen books. So we're going to do the unnest tokens function, which goes ahead and takes the word column and splits it into individual words. Basically, it's taking that text column, sorry about that, creating a new column called word, and it's creating individual rows for each unique word within the entire book. And then we're going to use that count function again. So we're going to take this data set, we're going to do some tidying of the data set, and then what we're going to do is use that count function, and what we're going to do is actually count the number of unique instances of the words that occur in each book. So let me kind of explain how that works. Actually, let me do this. So here, I'm going to take my book words, and I'm only going to run the code to here. So I'm just going to tidy this set of Jane Austen books. There we go. So I've tidied that, and let's go ahead and take a look at these book words. Excellent, there we go. So we have book, we have word, we have the book that it's from, and the actual word from the book. And what we're going to do is when we're counting, instead of saying, oops, there we go, instead of saying count every instance of this word across all the books, basically what we're telling it to do is to only count the number of those unique occurrences of those words for each book. So basically it's combining these together and doing unique counts for both of those. And then finally we're going to ungroup it at the end. So let's go ahead and run this whole set of code here. There we go. And now let's take a look at our book words. Okay. So there we go. So now we have the book, we have the word that's from that book, and we have how many times that word actually occurs. So you can notice at this point, and this is just for illustrative purposes, we haven't removed any stop words. So of course you're seeing lots of stop words. And that's actually going to be intentional for the demonstration later on. All right, so next what we need to do, so we've gone ahead and got the total number of occurrences of each of those words per book. So if we do some sorting here, there we go. So we're back to here. We can see that instead of counting the total number of instances of zealous across all books, it's counting by individual book here. All right, so let's go back here. Next, what we want to do is we're going to create a new data frame from our book words data set that goes ahead and counts the total number of words per book. And then we're going to tell it to group by book because we want to summarize this by each individual books. And then we're going to total this up. So let's go ahead and run this. And let's check out the total words that we created. So for Sense and Sensibility, we have 11,000 words. Mansfield's Park, 16,000 words. So let's go in here. Excellent. Again, you'll notice these, total words, there we go. You notice these word counts are higher because we haven't removed any stop words at this point. So we have these two data frames now. And again, this is for illustrative purposes. We were introduced to the anti-join in a previous lesson, which allowed us to remove stop words. What this is actually going to allow us to do is look for matches. It's going to look for matches between, give me a second, sorry. It's going to look for matches between book words here and total words. And then it's going to basically join on the total words to each of those words. I just want to make sure this is clear. So book words, we have book, word, and total number. And let's see, where's our total words? We just have book and total. So it's going to find, because book is the only column that's unique, that is identical in both of these columns. Every instance that it finds for Sense and Sensibility, it's going to add on a new column for the total number of books. Let's run that, and it's going to make more sense, I think, if you see it. And then let's go ahead and take a look at book words. So we can see down here, now we have the book, we have the word that occurs in that book, and you can see we have how many times that word occurs in the book, and then we have the total number of words that occur in that book. So now that we have our book words data frame here, we have the total number of times that this word occurs in this book, and we have the total number of words in that book. So basically, term frequency is simply just the number of words, the number of occurrences of that word divided by the total number of words in the entire book. And we can actually, if we wanted to, this is not in the text, but this is a pretty simple thing to do, is we can just calculate it and add this onto our data frame ourselves. So let's go ahead and use our little piping operator. Whoops. There we go. And we're going to use that mutate function that we learned in lesson 2 to create a new variable. We need to give this new variable a name. Let's call it tf for term frequency. And basically, we want term frequency, as we just mentioned, to be the number of occurrences of a given word divided by the total number of words. So we can just actually do a little operation here. In divided by total. There we go. So again, just explain one more time. We're taking our book words data frame up there, and we're going to mutate, which means to create a new variable. We're going to call that new variable tf for term frequency, and this is how we're going to calculate or figure out term frequency. So let's go ahead and run this, and then check out our book words. So there we go. We've run that, and we can see down here that now we have a term, the actual term frequency calculation. All right. So you'll notice, though, if we went ahead and looked up here, we'll see that the term frequency is not actually included in this data frame that we have saved to our environment. And that's because we haven't assigned this to the actual book words. All we've done is perform that calculation and just viewed it here, but we haven't saved that to our environment. So we could do a couple things. We could go ahead and assign it to book words if we wanted to go ahead and overwrite book words so that it now included the term frequency as well. Or we could go ahead and assign it TF if we wanted to do that for term frequency. So I'll go ahead and do that so I can create a new data frame here. And when we go and take a look at that, we can see it now includes the term frequency. I'm just kind of curious. Let's do some sorting here again. Yeah, and as we can see, term frequency by itself is not especially useful because it's going to be very similar to the word counts for the books. And The authors in Text Mining with R are going to go into this in more detail about why that's not especially useful. On the other hand, we will use that later for when we examine our term frequency inverse document frequency, which is going to help us to be able to identify some of these keywords or important words that are unique to individual books. So let's go ahead and take a look at this tf-idf function from tidytext in action. So as you can see here in chapter 3, authors do a great job of kind of walking us through how the function works and what it looks like, an example. And just to note down here, I did want to point out that we had calculated the total number of words for each book, but this function will do that automatically for us. So we won't need to do that at all. So the only thing we need to calculate effectively is just the count of words that we're going to be using. So that brings us to the point that this particular function, there's a few things we need to input. Of course, we need to tell it what the data source is going to be. In our case, we're going to use the book words data frame that we created. We need to tell it that we want to go ahead and find the tf-idf for our word column. We want to specify that the actual documents, in this case books that we're talking about, is going to be from the books column. So we want to do this by book. And then finally we need to tell it where to look for the counts of those individual words within the book. So let's go ahead and run this just for practice. So let's take this over here. All right, and we're going to go ahead and run this. All right, and again, we overwrote our previous book words data set, so let's go ahead and take a look at that. There we go. So we have our books now. We have our words, the number of times that word occurs, term frequency. So you can see that this is relatively higher than the others. The number of words, this is a very high word count, of course. But the value for these extremely common words, the, to, and effectively stop words, is 0. So what this really helps us do is if we go ahead and sort this, we can see that the tf-idf value helps us identify words that are common to a given book, but not so common as to be essentially useless, like those stop words, for instance. So let's go ahead and work through one final example using a new data source. This is a data source. This is a package for R called Gutenberg. I can't even say it without laughing, called Gutenberger. And this package allows us to basically import books from the public domain that are in Project Gutenberg. This is an excellent package, and it's one that I'm going to be recommending that you use for your final assignment for part 2. So let's go ahead and install that. I'm not going to run this code because I've already gone ahead and installed it, and as you can see, I've already loaded this package. Let's go back to our text. There we go, text mining with R. And it's basically going to illustrate how you can go ahead and import the books of interest. So let's go ahead and copy this over, and then we'll walk through what this code is doing. So basically what we're going to do is we're going to create a new data frame that we're going to call physics. We're going to take this Gutenberg download function from the Gutenberg package, and effectively what we need to do is we need to specify which books that we're actually interested in downloading. So in this case, these numbers here are book IDs from Project Gutenberg. So let's do an example of this. I'm going to take this particular book, and let's go to Project Gutenberg. Project Gutenberg, there we go. And I'm going to go ahead and browse catalog. Let's see. Actually, here I'll show you really quickly. Show you really quickly the education bookshelf. that I'm going to highlight later. And this contains collections of effectively books on education. So let's go to the catalog search there, and it's going to actually just sort them by popularity. So of course John Dewey books are going to be up here. We see some books by Maria Montessori, and if we clicked on one of those books, let's click on this Dewey book for example, you can see that this book is assigned a unique ID right here. And if we swapped out this ID, we could see that this is the particular book by Galileo that we would be downloading. So let's go back to our R code and let's go ahead and just run this. And effectively, we're telling it to download these 4 books, and we're using this combine function that we learned at the very beginning to combine those 4 books of interest into just a single list or a single vector of things we want to download. I'll show you later other ways you can go about downloading books. For example, if you wanted to download all books by a given author, we could do that. Finally, the last argument that I'm going to point out is we're just telling it here that we want to include the author of these books in our data frame. So let's go ahead and download those. All right. Oh, don't worry about that warning. If you get it popped up, we can actually see that the physics books have been imported. So we can see that they have an ID here, unique ID. We've included the author in our data set, and as you can see, each line of the book, just like with the Jane Austen books, it effectively created a single row for each line of the book, and we're going to need to tidy this up. So as you probably recall from lesson 3, we're going to use our unnest tokens function to go ahead and tokenize this text, remove stop words, etc., etc. There we go. And I'm just going to pull over this code from our text mining with R book. So we're going to take our physics data frame. There it is right there. We're going to take that. We're going to use the unnest tokens function. And we're going to create a new column called words, and we're going to take the text from the text column and go ahead and tokenize that. And then we're going to go ahead and use our count function. So we're going to effectively count the number of unique words that are used by a given author. Again, we're going to sort it, and then finally at the end we need to ungroup it because at that point we have grouped it by authors. So let's go ahead and do that. Let's run this code and see what we get here. Go ahead and take a look at it. And as you can see, we haven't removed any stop words, and that is completely fine because we're actually going to be we're going to be calculating the value of the term frequency, inverse document frequency. All right, as you can see, I went ahead and ran that. I ran into an error. Again, error is a typo. The name of my physics words, there we go. The name of the column that I'm pulling doing the tf-idf calculations for is called word, not words. Let's go ahead and delete that and run this. There we go. And let's check out the new data frame that I created. So we can see I still have author. I have words unique to that author, counts of those words used by that author, and then I have some statistics calculated. As we can see, if we just go by pure word counts, the occurs especially frequently in all the text. So let's go ahead and sort this and see which words come up for individual authors. So this is very interesting. So Galileo, we can see, talked about water a lot. Let's see, Nikola Tesla, bulb, coil. So we can get a sense, like really quickly, by pulling from all of these works by these individual authors, get a sense of what kind of physics topics or physics issues they may have been interested in or are writing about. And let's say I want to get a little bit more sophisticated with my ordering of this data frame. I can always go back to my arrange function here and specify the data set I want to arrange. I'm going to be arranging this one. I want to arrange it first by author, and by default it's going to be in ascending order. And then I want to arrange it by my tf-idf value, and I want to do that in descending order. So there we go, and let's go ahead and take a look at that. And excellent. So I can see some of the keywords for Galileo's just for this one particular text that we imported are water, Hathgrave, gravity, etc., etc. And if I wanted to go ahead and look at the whole data set there, the whole data frame, I could actually just save this as a new object, or again, I can just wrap this in a view function. And we all remember view from previous lessons, and we can just view this up here in the window. And there we go. So all of Galileo's keywords, and so on and so forth. So that wraps up lesson 4. Just to recap, we've learned to do some basic word counts and some term frequencies, and we've learned that word counts and term frequencies are almost synonymous. Things with high word counts often have high term frequency values, and a more useful metric is our tf-idf metric, which helps us identify key words in a text or common words to a given group of text, such as text by a particular author, and it helps us figure out which words are common, which words are sort of unique to a given text and are kind of common within that text, but not so common as to be stop words.